conic sections. And we obtain conic sections when we have a right circular cone and it's intersected by a plane. When it's intersected at a slanted plane, we end up with a parabola. When we intersect with a horizontal plane, we have a circle. When we intersect the entire base of the cone itself through a slanted one, we have an ellipse. And when we intersect vertically, we have a hyperbola. And that's where those come from. We're specifically going to focus on the parabola, the circle, which we've already done. We're going to do the parabola, the circle, and the ellipse together, as well as the hyperbola to focus. We're going to focus on all four of these. Today's focus is going to specifically be on a parabola. We know what the general shape of a parabola is. We've been working with it slightly a bit at this point. What will be new is going to be what we call the focus and the directrix. The focus and the directrix state that at any point that's on a plane is equidistant from a fixed line and a fixed point not on that line. And it's equidistant onto our parabola itself. So no matter where I put my point on the parabola, it is equidistant to the directrix, which is a line, and to the focus. We have a standard equation of a parabola if we are centered at the origin. And we have a vertical axis of symmetry, or we could potentially have a horizontal line of symmetry depending upon if we have x squared or y squared. If it's x squared, we will have a smiley face or a frowny face. However, if it's a y squared value, we will be facing to the right or to the left. The focus then, once we write it in its standard form, our directrix is going to be the line y equals negative p. P coming from the P of our equation, and the focus is the value 0p. So that P value is extremely important when we're looking for it. If our P value is positive, we'll open up, and if it's negative, we will open down. If our value is set equal to y squared, then our equation of the directrix is x equals negative p. Again, when we put our equation in form of p. The focus is also P0. The x-axis is the axis of symmetry then. And when P is greater than 0, we will open up to the right. And if it's less than 0, we will open to the left. In our first example, we have find the vertex, the focus, and the directrix of the parabola. Y equals negative 1/12 x squared. I notice that I have x squared. Since I have x squared, that is my indication that I'll need to try to make it into this equation. X squared is equal to 4py. To do that, I need to get x by itself. So I'm going to multiply everything by negative 12. When I do that, I'll have negative 12y is equal to x squared. And now we need to put it in the form of 4 times a value times y. So I can rewrite negative 12 as 4 times negative 3. So now my negative 3 is my p value. Then I know exactly what I need to find the vertex, the focus, and the directrix. Now that I know my p value, my directrix is y equals negative p. So y equals the opposite of negative 3, which is positive 3. Our vertex is still going to be 0, 0, because we put it in the standard form. And our focus is 0p itself, or 0, negative 3. So now that I have my directrix, which is a horizontal line, and I have my focus, I know that any point that's on the line of my parabola is equidistant from the focus to the directrix. Let's find an equation of a parabola if we have a vertex 0, 0, which means that we are centered at the origin, and we have a focus of 5, 0, then graph the parabola. That 5, 0 tells me that it's on the x-axis, so my focus is on the x-axis, so that I know I need to use the formula y squared equals 4px. Well, if I know the focus, I know the p-value must be 5. Using and substituting those values in, I'll have y squared is equal to 4 times p times x, so y is equal to 20x. And utilizing decimals, we can help graph this by also including the focus as well. What happens if our parabola is not on the origin? We need to use a different standard form where our vertex is hk. So we'll use these formulas when we're not on the origin. We have a vertex of hk, whatever that vertex might be. It has a vertical axis of symmetry is listed. Where the vertex is hk, the focus then is h, and then our k plus our p value, and the directrix is given by y is equal to our k value minus our p value. Similarly, if we're going to have a parabola that opens right or left, we'll have our same vertex at hk, except our y and our x values are interchanged when we're looking for them. So keep these formulas handy. We'll utilize them on the next example here. For the parabola, x squared plus 6x plus 4y plus 5 is 0. Because we have an x squared, that is our hint to use this formula. Because of the x squared. Since the x value is squared, it is our hint to use the a vertical axis of symmetry portion. We need to complete the square in order to get it into standard form. So what I'm going to do is put all of my x's on one side of the equation and everything else on the right-hand side of the equation, which means I'll need to subtract 4y and minus 5 and bring them to the right. We're going to use completing the square so that we can get it into this form here. And completing the square is going to be a commonality that we're going to utilize. So to complete the square, I look at my value of 6. I divide it by 2 and square it. This gives me 3 squared, and 3 is the value that we're going to need for both sides. And this equals 9. So I want to add 9 to both sides. I can factor the left-hand side. Using this piece here right before we square it, it helps us factor, so x plus 3. And combining like terms on the right, I'll have negative 4y plus 4. We need to make sure that we currently have the x minus h squared piece, but we need to have 4p times y minus k. Right now we don't have that. So I'm going to factor negative 4y plus 4. I'm going to factor out a negative 4. When we do that, then we're left with negative 4 times y minus 1. We need our p value. So right now we need to say 4 times what gives me negative 4? Well, 4 times negative 1 gives me negative 4. I also can rewrite x plus 3 squared using subtraction because I know that's the same as x minus a negative 3. And now we have our values. We have our h value, which is negative 3. We have our k value, which is positive 1. And we also have our p value, which is negative 1. Now that we have those three pieces, we can find the vertex, the focus, and the directrix. So to find the vertex, it's HK. So HK is -3, 1. So here's our vertex. We can find our focus, which is our H value, and then adding K plus P. So 1 plus -1 gives us 0. So -3, 0. Even though it's not listed here, this is our focus. And our directrix is y equals k minus p. So 1 minus -1 is 2. So when y is equal to 2 is our directrix. So we would have a directrix here. And of course, utilizing Desmos to help us graph the other parts of the parabola itself. In our next example, I have y squared minus 2y minus 8x minus 31 is 0. Find the vertex, the focus, and the directrix. Well, notice now that I have a y squared. Since I have y squared, that is our hint to use this formula here. The piece that is squared will determine which formula we'll want to use. We'll then want to complete the square again because we need to get it into its certain standard form. What I'll need to do is add 8x and add 31 and bring it to the right hand side so that all the y's are on the left and the x values are on the right. I then take my -2 divided by 2 and square it. This gives me -1 squared. This is the part we're going to use when we're factoring, and -1 squared is 1, so we add 1 to both sides. This gives me then y minus 1 in its factored form, again using this piece here. And then we'll have 8x plus 32. On the right, we want to factor. I see they both are divisible by 8. But we also need our p value. So 4 times what gives me 8? So 4 times 2 is 8. And then writing using subtraction, x plus 4 is the same as x minus a -4. I know all of my values now. I know my h value is -4. I know my k value is 1, and my p value is 2. Now that we know all that information, we can pull our vertex, our focus, and our directrix, given the formulas from the previous pages. So our vertex is HK, so -4, 1. Our focus is H plus P, so H plus P would be -4 plus 2, or -2, and our K value of 1. And our directrix is X is equal to H minus P, or X equals -6. So our directrix, is x equals -6. And our focus, we just found, was -2, 1. And each point is equidistant on that parabola from the focus and the directrix. Y equals x squared plus 6x plus 10. We want to find the vertex, the focus, and the directrix. Because I have x squared, I know that I'm going to be finding a vertical axis of symmetry and utilizing x minus h squared equals 4 times p times y minus k. So I'm going to get all of my x values on one side and all of my y values on the other side. All of my x values on one side and all my y values on the other. So if I were to subtract 10 from both sides, I would have x squared plus 6x equal to y minus 10, just rearranging them. I'm going to take my value here. We're going to have to complete the square. So I'm going to take 6 divided by 2 and square it, which is 3 squared. This is the part we'll use for factoring. is equal to 9. So I want to add 9 to the left and to the right. So its factored form on the left is going to be x plus 3 squared equal to y minus 1. Notice then that currently we have this value of y minus 1 with a 1 in the front. But we need 4 times what gives us 1? Well, 4 times 1/4 would be 1, so that we have our p-value. So sometimes we have to manipulate a little bit in order to get there. So 4 times what gives us 1? Well, 4 times 1/4 would be 1. On the left-hand side, rewriting it so it's in subtraction, we have x minus a negative 3 squared. We now have the pieces with which we need in order to find the vertex, the focus, and the directrix. We have our k value is 1. We have our h value, which is negative 3, and our p value, which is 1/4. So to find the vertex, using the definition on the previous page, is hk. And hk is negative 3, positive 1. Our focus is hk plus p, which is equal to negative 3, and k plus p, 1 plus 1/4, would be 5/4. And our directrix is y equals k minus p. So our k value is 1, and when I subtract 1/4, we will have y is equal to 3/4. Our last one here, I have y squared minus y minus x plus 6 is 0. Again, I see that I have my y squared value, so that tells me we need to use the formula y equals k squared equal to 4p times x minus h. Getting all of my y's on one side, I'll have y squared minus y is equal to x minus 6 when I add x and subtract 6. I need to take my value here, so negative 1 divided by 2 squared, which is going to be a fraction, so the negative half is the part we're going to use when we factor, which is a really nice and convenient, is equal to 1/4, and I'll add 1/4 to both sides. Its factored form then is y minus 1/2 squared equal to x minus 5 3/4, since negative 6 plus 1/4 is 5 3/4. Similar to what we had on the previous example, there is a 1 in front of here and we need our p-value. So what can I multiply 4 by so that we get 1? Well, 4 times, again, 1/4 is 1, and then we have x minus 5 3/4. On the left, we will still have, since it's all written in subtraction, we have y minus 1/2 squared. We know some of our values. We know our k value, we know our p value, and we know our h value. Our vertex then is hk, and hk is positive 5 3/4 and positive 1/2. Our focus is h plus p k, and h plus p would be 5 3/4 plus 1/4 would give us a total of 6, and our k value is still 1/2. And the directrix is x equals h minus p, And when I have 5 3/4 and I subtract 1/4, we have x is equal to 5.5. And this concludes our lesson on finding equations of parabolas using the vertex, the focus, and the directrix.